Okay, this is a heat transfer problem. This is basically what you did in the lab. So I've got a piece of metal that I heat up and then I dropped it into a beaker of water and it gives you the final temperature. You want to find the specific heat of the metal. This is exactly what you did in the lab. Okay, so let's refresh you. So again, it's helpful. So we'll call this the metal 1 and the water 2, right? So M, C, and then your initial 1, M, C, and your initial 2, because they both have the same final temperature, right? So that number right there, equilibrium temperature, that's TF. So the mass of the metal is 0.05. This is my number, right? Don't use my numbers, use your numbers. This is 0.4 kilograms of water. And the initial temperature of the water is 20 degrees C. And the initial of the metal is 200 degrees C. And the specific heat of water is 4,186. And I'm trying to find the specific heat of the metal, right? So this is M2, C2, M1, C1. Okay, so metal equals water. The heat lost from the metal, the Q lost from the metal equals the Q gained by the water. So MC delta T for the lost from the metal, right, equals MC delta T for the water. And I'm going to put a negative sign on this side because that's the side that lost heat, right? In order to make these numbers be the same, right? Because I can't have a negative equal a positive. This, because it's lost, it's going to be negative. So I'm putting a negative sign here to get rid of the negative sign just to make the math work, right? The other way you could do it is change the order of final minus initial. So you could make this initial minus final to get rid of the negative sign. Same thing. Okay, that's why when we did the lab, you ended up with a negative number. We just need to use that negative. Okay, anyway, so now, okay, let's rewrite this as delta T. So M1C1 times T final minus T naught 1 equals M2C2 times T final minus T naught 2, right? And this is exactly, again, this is what you did in the lab. So you're solving for C1, right? So all I got to do is some algebra. So M2C2 times T final minus T naught 2 over, right, M1 times T final minus T naught 1. And I'm done. And so again, both of these have the same final temperature. Mine's 22.4. Right, so just make sure you use your numbers. And then that'll solve for C1. And you can check yourself because you have a metal, right? So this should be, I don't know, between like 300 and 1,000 maybe. So you can solve for C1 and it's all in base units and I don't have to do any conversions, right? So same thing, just like we did in the lab. Set the two heats equal to each other, move your stuff over, solve for specific heat.